Which one? Like the name? Oh, you can just like call Leonard. That's fine. Leonard, like the guy from Big Bang Theory. That's kind of the most convenient, I guess.
That's what most people call you, Leonard?
Yeah, that's fine. That works.
The LS dash big G doesn't make different colors on my.
Okay. Which terminal are you using? Or like?
Machines and also in Mac.
Okay, that's odd.
LS dash
Minus.
big G.
Yeah.
If I go to a place where there are files versus directories. It doesn't say so. It doesn't say that it will do that in the manual either.
Okay. So this is kind of missing, right?
What is it?
Like if you just type like ls minus g, this is not working?
Word. It doesn't make blue.
Okay, that's odd. Yeah, I think that's like kind of something to debug best like with TAs or office hours.
But also in the manual, it doesn't even talk about that.
Is it ls dash big?
Okay, that's weird. Yeah, we can take it after lecture. Alright, good. So, welcome everyone to the third lecture of CS6 Practical System Skills. Last lecture we talked a lot about files and directories, copy commands, move commands, and the coolest new thing we learned were like Unix wildcards. And today we're gonna continue that mission regarding getting the most out of files that we can do. And that's like we're gonna talk about users and permissions. So this is gonna be the first huge block of today, and then after that we're gonna talk a lot about like streams, redirection, and pipes. So let's start a little what like kind of the base of all of this is, and that is Unix is a multi-user system. So you might have experienced that if you log into the department machines. It's not only you who controls that device, but it's many people more. And so because it's a multi-user system, there are like kind of some essential questions. The first, like, how do you protect files from other users, the world? How do you share files amongst different users and groups? And also like one important question, and that's like, because as we learned like last lecture, there is no easy way to undo your actions in the terminal. So you also want to protect yourself sometimes from yourself. So users, what kind of users do we have? So there's like kind of two views on users. One is like more the logical thing, so everything that's kind of real, and one is how the operating system sees users. So what kind of logical users are we typically having like in a Unix environment? So first we have one special user, that's like the root user, and that's the account that has unlimited rights. Then, because having unlimited rights, of course, is a lot of power, but not very practical, there are usually one or more admin accounts. So these are the accounts usually operated by T-staff here in the department. And then we have regular users, which is like you and me and everybody else who's human or pretends to be human. And last, we have another important category of users, which are technical users. And these users are typically used when you deploy your applications on a computer or server. And the idea is that you basically create a fake technical user which runs that program and has restricted privileges. So we're not going to do today like how to add users and give them the proper rights and so on, because this is more like a deployment section, which we will do later in the course when we're deploying our web applications using like a Flask server. However, it's kind of good to know at this stage already what type of users exist. So how does Unix see users? Well, we have like the logical view. Unfortunately, it doesn't map directly to like what's in the operating system. And so how Unix sees users is like kind of in three categories. First, we have the owner, which is like typically the creator of a file. We have a group, which is made up of multiple users. And then we have all the rest, which is like basically all the other users or the world, basically. And so each file is owned by a user, which is typically the creator. And I say typically because there's one exception how a file can be owned by someone else than the creator, and that's like if the root account decides to transfer ownership to another user. But of course you need root permissions to do that. And in addition, also each file belongs to a group, and the smallest group that exists on Unix is just one user. So how can we give or protect our files by like permissions? Well, so each file in Unix has 3 basic permissions, and that's like read permission, meaning the file can be read, in the sense that you can just like read out the contents, display it using like cat or like any other command. Then the write permission, which says it can be modified and important also deleted. It can be executed, and that's like relevant for executables or scripts, which is kind of the topic for next week. So what can we now do in the Unix sense of users? Well, I already mentioned we have like these 3 categories. We have the owner, the group, and other. And so Unix allows you to set for each file specific read, write, execute permissions for each party. That means you can assign the owner some permissions, you can assign the group some permissions, and you can assign permissions to the rest. A little different view happens when it comes to permissions when we're talking about directories. I mean, if you remember from the first lecture, it was like everything in Unix is a file in the end, so also directories are like files. However, here the meaning differs a little when it comes to permissions, and that is like, whereas for file it's pretty straightforward, you know, you can read it, you can write it, you can execute it, and it makes all sense. For directories it's a little odd. So first of all, if we have a read permission for a directory, that means that you can basically read all the file names under this directory, which means basically if you give a directory read permission, you can execute the list command and see what's under the directory. Same goes for the write permission. So if you give a directory write permission, then you can modify the entries within this directory by like just overriding them, adding them, removing them, and so on. And another important one, and that's like the oddest, is like the execute permission for a directory. And that is like you can access the contents, meaning all the things below. So you basically need both. You need read and execute to know what's inside a directory. And you can also access metadata, like file sizes and so on, creation date, blah, blah, blah.
I want other people to be able to copy a file that I have in a directory.
Yes.
Do I need to give them permissions?
Yes, that's exactly what we're going to talk about, and we're going to deep dive into what permissions you have to set in just a couple slides. And if the question is still done, then let's answer that then. Also, just in case, if you want to check out the slides, I always upload them shortly before lecture, so they're always online on the website in case you want to take notes on slides or so. All right, this brings us exactly to this question, and that's like, first, before we assign permissions, we want to know what kind of permissions exist for a file. And we had already kind of a shortcut in the last lecture when it comes to list, and I was like, there's like this -L option for the long format, but I was like skipping over. And usually when I skip over stuff, that means it will return later or sooner. Today is like kind of sooner, and that's like the long format for list. So let's dissect a little what's happening here. So, I mean, here I run the list command. I first get like a total, which is just like the total of bytes stored, and that's not the number for like the files, but more like how much space basically the meta information, like the tree, takes. And then I have here the thing that's kind of the main topic today, and that's the permission string, which says what permissions this file has. Then I have listed who owns the file and the group the file belongs to. And then, of course, some metadata, which is like the file size, the last access time, and the base name of the file, or the file path.
Are you also going to say what the 1 is for C-line?
The 1? Yes, the 1 is the number of hard links, but like you basically can ignore that most of the time because it's not that relevant at this point. So when we talk about the permission string, we basically see that there's the option to have 10 dashes. And each dash basically means if like a certain flag or bit is set for this permission string. So the first dash is the file type, which can be D for directory, for example, or it's just a dash if it's a regular file. Then we have the permission bits for the user, the group, and the rest. And so basically each of these like 3 permission bits is again kind of dissected into like read, write, and execute, and the order matters. And so basically, if the permission is set, then you see the letter. If it's not set, then it's just a dash. And yeah, you might have noticed that I will talk about users and owners pretty interchangeably, and that's like because like kind of when it comes to permissions, it's often the same, though it's technically not the same. But for permissions, usually says, okay, I have like user permissions, or give it user permissions. You mean basically give permissions to the owner, but it's always the owner of the file. Let's dive a little deeper into the permission string. So as I said, it's made up of 10 characters. The first one refers to the file type. We have a bunch of options. We just create out the ones that are like kind of not super important at this point. But there are like 3 options which are important, which is like a regular file, which is a dash, then a directory, and a symbolic link, which I will introduce in a couple slides. And then, as I said, we have like the other symbols to say like, yeah, the file has like read, write, execute permissions for the certain group, like user group or other. And so the important question after kind of knowing how to get the info, permission info for a file is how can we change the permissions? And for this, there's a handy command which is called change mode. And you give it first a mode and then 1 or more file names. Of course, you can also use Unix wildcards. And the trick about this command is that in order to run this command, you have to be the owner of the file, which kind of makes sense. Or as like an exception to pretty much every rule on a Unix system is when you're the root user, you can run anything and you have any rights. That's why it's critical to never get or like allow someone to gain root rights over your system, because you can mess it up pretty badly then. So when it comes to mode, there's like kind of 2 options how to specify the mode. One is using a couple numbers, and one is using a combination of symbols. Let's start with the easier one, which is the symbolic mode for mode. So first, we kind of can specify which party we want to set permissions for. Then we can perform an action, which is like add the permission, remove the permission, or set the permission exactly to something, and then the permission itself. So how this works is basically here, I change the permission in the sense that the user / owner gets read-write permissions, the group gets read-execute permissions, and all the rest get no permissions. So when I would list that, that means like I would like get basically the string minus rw minus r minus x and 3 dashes back.
Why would the user not have execute?
So for example, if you have just a file, right? And you have to think the file is always just bits and bytes. And you give it execute permissions, then maybe somebody dropped you a malicious file that you just downloaded over the internet, and accidentally you run it by just like executing this file. There could be code hidden, and this code could take over your computer, and then you kind of are locked out. Because once somebody gained root access to your computer, you're basically screwed. And in order to prevent this, you can just disable the execute permission, so then you can just read-write the file, but you can't execute it, so you can't load basically the file contents into the CPU as code. All right, the second mode I want to talk about is the numeric mode, and that is like, as I said, terminal users are lazy. They always prefer to write less tokens, and so as you see, this kind of permission thing set up like there with like symbols is rather long, so it's easier to just write a couple numbers. And in fact, like when people talk about permissions, often just the numbers are mentioned. So something along the lines like, yeah, just give this file 650 permissions, or yeah, this directory should have 700 permissions, right? And what they're referring to is basically just a numeric mode that you want to set these files to. So how you can do that is, again, you just use like change mod, you give it a couple numbers, and then like the files you want to change it to. And so there's basically one simple analogy how this comes together, and that is like, you can always think of these permissions as bits that are like set or not set. So it's basically a 1 if it's set or a 0 if it's not set. And that directly corresponds to a string. And because we have binary digits, we can also just see them directly as octal numbers. So we just count from like 0 till 7, right? And so we can just set, like, for these 3 parties, the permission directly by just providing 3 octal numbers in a row. And this is exactly what we do. So here we have like kind of 6, which is like 4 plus 2. So we have read-write. We have 5, which is nothing else than 4 plus 1. So we have read-execute. And then we have 0, so no permissions at all. So that's why we kind of just have, in the end, 3 dashes for the other group. And as you see, it's like rather quick. It's pretty fast. And also in the end, when it comes to permissions, at some point you will just start remembering certain numbers which fit most of your use cases. That was a question here.
Will the order always be users, groups, and the other?
So for the symbolic mode, you can mix it up. And it's just read basically from left to right. So if you write something like user equals RW and comma, user equals X, then it will be only the X permission, because I use like equals. For the numeric mode, though, the order matters. So there it's like really always user, group, other. And just because it's kind of standard, I would recommend not to mix up the order. Yeah.
Is it a common permission 650?
That's like one common permissions.
So the rationale you were explaining before for why the user would want to have execute permission,
Yeah.
why would you give the group then execute permission?
Because, for example, okay, this is like no one special case, right? So this could be something along the line. You have deployed a web server. This web server runs with one group, and it wants to execute a code file. But you yourself are working on this file, and you don't want to kind of execute it or screw it up or something, and you want to feed it into this process. So then you could use, for example, 650 permissions. However, on this slide in particular, I was not thinking of like one specific use case. This is more like how to decode it. But yeah, you're totally right. But as it comes to permissions, it's kind of, yes, you need like some use cases. And that's also something which I will talk in the next slides about, what type of permissions can be used for which use case. Because after all, it's practical system skills. Yeah.
Who falls under the others group?
That's every other user, which is not part of the group.
Okay.
And I have to say also the owner, because technically a group can belong to a file of which the owner is not part of. All right, so let's go one more example over numeric mode. So as I said, you can basically see this as like bits and bytes, and the basic trick how to quickly go to these permissions is you just have to remember one lookup table, and that's like 4 equals read, 2 equals write, 1 equals execute. And so if you want to combine permissions, you just add them together. Meaning if I want to have read execute, it's 4 plus 1, it's 5. If I want to have read write, it's like a 6. If I want all of them, it's a 7. And that's basically how you quickly go to like permissions. That was a question over here. Done? All right, perfect. All right, again, let's take a look at list long format. So we already know, like, we have like some penguin who's asking. We can kind of answer the questions: who owns the file, what permissions does the file have, and what type of file the lecture is. And I'm kind of iterating over this because it's a very important concept and it takes a while to learn. So I highly recommend to kind of spend some time going over it and just trying out reading all of this. So again, we have here an example using list long format where we have this time a directory. We have the writes. Then, as I said, like this number is the number of hard links, but don't care about this yet. We'll talk about this later in the lecture. Then we have the owner, the group, and we have file size, last modified, and path name. So this is like kind of one complete example dissected. All right, in order to kind of practice this a little and have some fun with numbers, I prepared a little quiz. And because I don't expect anyone to make some notes, if you want to take part in this quiz and have some fun adding bits and bytes, I just printed out a couple copies. And yeah, let's take maybe just like 3 minutes to have some fun filling out this quiz. So we know in the next slides what these permissions mean. Just a couple of slides, just these passed along.
Nice.
Oh yeah, thanks. And of course, please collaborate on that. You can talk, help each other. Like it's a learning experience, so it's not a test or so.
Oh shit. So that's is 7. Oh. So these so just nothing. The bars this is 707.
We need 3 zeros. You're setting users, groups in
Three.
so
Yeah.
Is like the whole first row like correlated?
Yeah. It's like kind of you have the file before. Permissions were set. That's the original state, right? Then you run the symbolic mode. Then you want to file out the kind of corresponding numeric mode. And then you want to fill in what the file looks like after you run either of these commands.
yes, this is your 7 zeros.
Yeah.
6, but it's sort of
Oh yeah, but like so
Because like
this is
all of them
basically
are zeros
as
now,
it has
it's
it
all
before.
dashes.
Because you can also add permissions or remove permissions.
Because you don't put nothing in
Because
symbolic.
equals.
Because this is at your choice. You're not supposed to.
Based on what we see here.
Yeah.
Oh, okay, I see.
But you still have to do change mode 000.
So that first one
Oh,
was
it's one more question here.
yes, this is the time where you should be rewrite at the very beginning.
Yeah.
Well, my ears are plugged, that's why.
So those are
No, I use that.
just do that.
Yeah, so that means that there's no more permissions. So here, it's just based on this guy. So ch mod u equal rwx, g equal rwx. Because it's 777. No, it's not. It doesn't work. Well, I'm lucky.
Yeah.
Yeah, but you're supposed to fill this guy. With c mod u equals rwx.
That's before. Command. Out of nowhere.
Yeah, so I'd say like let's give it till half, and then we can kind of get to the solutions.
That's one. Just X itself. That's cute, just one itself.
Is the last one valid?
What do you mean by valid? Yeah, it's completely fine.
So just take like the last one.
Yeah.
Yeah.
U plus R is not going to throw incorrect syntax.
You mean like the U plus R? No, because like you can basically use the plus or a minus to add or remove permissions.
You could also say like U plus R.
The second example.
Yeah.
Before you gave user right permission. Yeah.
And then the others right rewrite.
So what's the third one?
This is over. That's fine. But that might have. I don't know if that was already done.
Oh, it's like this. So numeric mode would be the. So what is this thing? X is 1, 7. Oh, what the heck is this? U plus R.
That's like pattern.
Oh, so it. But it doesn't have permission to begin with. So then you give the question mark if permission to can be given up. Oh, because you're adding Thursday, right? No, that's right. This is going to be R W dash. So then numeric mode is just. Yeah, because we're actually saying numeric mode is R W. So it's 600.
It's interesting. So if you're changing it, you don't have to use stuff if you're using a symbolic method. If you're changing it and G or you
No.
you actually do other stuff.
But the numeric method is like social method.
What?
It's a VR class.
This
You're also yeah, you get to use it and make it coding. Sorry. Like I can get to programs.
plus
Things like things we have to consider. Yeah.
I have a quick question.
Literally
Yeah.
just on
Wait, this class, like mandatory SNC,
Yeah.
so on banner right now it says there's a great option.
Is it? Alright. Okay, good. Good to know. Yeah, so as far as I know, it's mandatory S&C, but like, yeah, I'm gonna check it. I mean, I was also not aware of that like 5 seconds ago. Thanks. Alright, cool. I would say let's have some fun with permissions, alright? Good. The first one, any suggestions for the numeric mode?
0, 0, 0.
0, 0, 0. Yeah, that works. I mean, I just like put on like here a couple files with like these permissions. So, and yeah, as you said, if we just run 0, 0, 0 on the first one, what we will get is basically only dashes, and that's exactly the same as like the change mod.
Wait,
You-
so if you try to open that text file, you can't open it.
Well, let's check it out, right? What does it say? Permission denied. So, yeah, it doesn't work.
What is the exclamation point after they can do? Like, don't save your changes.
Yes. So if you, oh, they didn't do that in the lab.
We played a game.
Oh, okay, sure. So I mean, if you do Vim, right, like there's like kind of one option that's like quit, right? And if you just do the exclamation mark after it, you ignore all the changes that you do, yeah. Which is kind of sometimes what you need to do if you're like in a file where you don't have permissions. Alright, cool. Yeah, so we have numeric mode, file permissions after just dashes, so we're good on this. Let's go to the next one. Any suggestions here? What should I run? Symbolic mode.
Korea RWXs.
So you would say, like, something like this?
Wait, the second one?
Yeah, the second one.
RWX for all.
Oh, RW, sorry. Yep, that would work.
Break ahead.
Yeah, is that the only solution?
I just have a question. How do you make a group? You know, because how you said the permissions for a group.
Yes.
How do you actually make a group? Or other person for that matter?
Yes, so there's basically a command for that, which is called, I think, @group or group @, one of these. And then you can create a group using that. But we're going to talk about that when we do like deployment for like these things. Because I don't want to go yet into like user administration. First, we're going to do like file permissions.
If you did U plus RWX, would it work just as well?
Yeah, would work as well. So you can also like change it. And like as I said, it's basically always a question of like how fast or how what you want to do, right, to get somewhere. So yeah, if you get this, you know, we get like the permissions, like the 777 permissions. So it's everywhere written. All right, cool. Let's go to the third one. There's actually a typo, as someone nicely spotted out. The first dash has to go and go somewhere else. So sorry for that. Will be corrected in the slides. Anyways, nevertheless, what kind of symbolic change mode could we run to kind of get to the 654 permissions? Yeah.
G plus RX, O plus R.
So G plus RX and O plus.
R.
Yeah. Okay, let's check it out. Of course, the number 3. And then we have RW, right? So we have 4 plus 2 is 6. We have RX, which is 5. And we have R, which is 4. Yeah, so that's also correct. Cool. How about the fourth row?
We're in 3.
Yes.
So why is there an extra X?
So we have here, this is the user, right? Then we have here the group, which is 5, so 4 plus 1, read and execute permissions. And we have, for the other, just read permissions, which is 4. All right, the number 4, any suggestions? Let's maybe start what the file permissions before could have looked like.
It would just be blank X and then everything blank.
Yeah, so yeah, the truth is like, so you basically here you have just defined that the group and the others would have RWX permissions, right? And the rest is kind of arbitrary because you could either set the X right edit or it could be there before or not. So it's completely arbitrary. All right, let's move to the next one. Let's do quickly the numeric mode. What's U equals X in numeric mode?
177. Or just 1.
Yeah, 177. Yeah, not because you want to 7, so you want to make sure it's after like RWX, so you want to use
You
7.
just put like 1 for the order. You have to have 3 digits.
Wait, wouldn't it be 100?
Yeah.
So just use X.
So you want to have 3 digits, yeah, because you want to specify where it is.
Well, we do it based off using the X or the last file.text permission after.
Well, so the trick here is like how it works. I mean, it's kind of a mini Sudoku, right? So we want to set the user to X. So this is going to be a 1, right? Mm-hmm. And then we have to kind of enforce that there is like full permissions for the group and the others. So we have to force it to 7. Yeah, so we use like 177.
Can we do like 100? Is that a thing?
Yes, of course, but like this won't give us the result, right? Because right now we have 4 after has here RWX, right? But with 0 we would clear it out. Okay, cool. Yeah, I think we're good after like these 4 entries. There are like solutions in the slides. And so basically the idea of like this whole quiz and why I did it is like, as you might have noticed, it's not impossible to get like to quickly fill out permissions and so on, but it takes some practice. And I really highly recommend to practice this a little because it just makes your workflow so much faster if you know the permissions. Cool. Next, let's go to how we change ownership. So there's like 2 commands you can use for that. One is like the change owner, so chown. And here we can assign actually both things. We can assign an owner and a group by just like basically listing an owner, then a colon group if you want to do both in one command, or we can just assign an owner or just a group. And there's also another command which is change group, which is actually not really necessary, but this does basically the same as like if we just use like change ownership and just run with like a group. And so for example, if we create a new file, share this file, and this is run by user Tux, then Tux can basically share this file to a group friends by just like owning it to the friends group, and then it gets like friends. This brings us to the most important question of today, and that's like when to use which permissions. So there's kind of some lists that I just compiled, which is like some permissions that help you along kind of life in a Unix terminal. So the first one is like, you want to protect your files from everyone else. What do you use? Well, there's 2 options. You clear basically group and other, so you give it 700 or 600 permissions. And you set the execute bit depending on whether you want to run it as a script, or if it's a script or not. But like in general, the advice is be always as restrictive with your permissions as possible. So better less permissions than more permissions. Second one is like you want to protect the files from everyone else, and you also want to make sure you don't overwrite them, just like by accident or so, which effectively makes your file read-only, and for that you basically use 400 permissions. There's also some files on your system that actually require you to have restrictive permissions. So anybody has probably one idea which files could benefit a lot like from 400 permissions. Like what would you store in such files? Yeah.
Historical things that you created.
Yeah, that's one option. And what's way more important? I mean, that's also very important, like a backup, but passwords. So if you have passwords or login credentials, you want to have them with like 400 permissions, so no other attacking user or so can write or overwrite your secret. Because that would be a very bad idea, right? Because you would be locked out from the system in the worst case. So that's why typically key files are stored with 400 permissions. We have 2 more, and that's like only you can modify files, others may still read them. So this is like kind of a nice setting to have towards the world, which is also, I think, the default if you log in into department machines, so 644. So basically you can browse other users' files, you can read them, but you can't write to them and you can't execute them. Then we have one more that's a little more open, which is basically the same, just like with like execute bits. So some systems also use that as a default permission for newly created files. So, I mean, both of them are kind of fine if you just want like a general file setting. And then we have one other interesting permission, and that is like you basically give yourself full access and the others executable access. And so this setting is one that's in particular used for directories. And that is so you can basically browse and traverse them. There's also a default guide that I just put in the slides. So we see it kind of goes like from more open to more restrictive and what you should use. And there's just one thing I want to stress. I mean, in the end, it depends on your use case and what you want to do, right? But in general, never use 777 permissions and don't use 666 permissions. Yes?
So just like under the Brown network, like what would you consider other? User would be like our own usernames.
Well, so if you log in, right,
Yeah.
and you list a file, you get your user. Then I think Brown creates one special group just for you, which kind of accumulates a couple other technical users just for the administration. And that's like what you get as default, just to protect yourself. But other is basically everybody else here in the room,
Oh, okay.
everybody else who has access to the cluster, the root user, and so on.
Okay.
And also like the admin users. So that means if you want to kind of hide your files from everyone else on the cluster, just put your files to like 600 or like 400 or 700. All right, there's one more thing regarding directories, and that's like, please don't delete the execute bit on your folders. The reason for that is basically if you would set a folder to like 400, so read only, you can't cd or list into them. That's because cd and list are in the end programs, and they need execute permission to kind of go to your folder or read the contents of it. And sometimes, so if you encounter a problem like cd somewhere and you're sure, hey, this is my folder, I own this folder, and I can't get into it, this could be a permission problem. Meaning you should just like change it by using chmod 700 path to kind of solve this issue. So because of, sorry? Path is just any file path, whatever file path. So if you want to do like cd path, right, and you disable the execute bit there, you can't cd into this path. So because for this reason, for folders, slightly different permissions are used, and that's like 700 if you have a private folder and you want to still traverse it, but nobody else can do that. Then 711 if you want all your files and things to be private and read-only, and so you can get like, the stats on the folders, but others can still see the directory structure, or 755 if you want to share your files and your directory structure. And yeah, the notice you can also use 770, that's also fine if you can live with like others from the group modifying your folders. All right, let's have an example here. So actually, yeah, let's make this live and hope it works. Just to kind of have a little fun. So I created 2 users. I hope one can see that. We have cline and tux. Both, of course, start in the home directory. And so let's say cline wants to know what tux is doing. So he can basically list the folder. And he can also like check out what permissions these files have. And he sees that tux has a little secret there. And so he tries to access the secret of tux, but unfortunately he can't do that because the group is emptied and others are emptied, so it's read, write, execute only for tux. So he gets a permission denied, right? Yeah.
Is cline in group or?
So we see here, we have kind of the files listed, like we have home tux listed, right? And we see the file tux secret is owned by tux, and the group is also only tux, right? So, and we have one file that's open, which is like kind of tux profile. So if we do, right, we can see there's like tux basically in it. But yeah, for the other file, it doesn't work. And so the same kind of can be done right in the other direction. So we have cline, who also has like some secret or so. And we see here it's even more interesting because here, because it's all denied, we even can't get the permission info. Because basically what I did here is when I go minus L home, oh sorry, this looks complaining. Yeah, there we go. Here I basically disabled for the cline directory the execute bits, thus I can't list the information on them, which is kind of the cool thing. So here you can basically even prevent others from seeing what permissions you have for the files in the folder. And of course, we can also just for fun discover what the secrets are. So let's check out what cline secret is. Okay, we're at tux, so we get a permission denied. So we kind of have to swap it. So only Tux can read his secret. Let's see what it says. All right, Tux actually doesn't like C-lines. And if we go to C-line secret, we can also see that. And we see that C-line actually likes to eat penguins, but Tux he likes, so he doesn't eat Tux. Meaning, just like this kind of fun example shall illustrate why you want to protect your secrets using file permissions. And yeah, of course we can do a lot more things there and like kind of protect our files in weird ways. But the general advice is like kind of stick to like restrictive permissions, so use 600, maybe 400 if you want to, 400 for sure for your secrets that you don't want to overwrite. And for the folders, be aware of like kind of the execute bit, that you set the execute bit just to allow the listing and traversing. All right, I also put all these examples on the slides. So we have, again, yeah, C-line wants to access home tux. He gets like kind of the permission error, which is basically what I just showed. Then we can kind of see that, yeah, in the other setting we have like the folder where we have like the execute bit set, right? So it kind of works not out that you can't like list the directory and you can't open it, right? But if you know the file path, you can still do that because we have like 711 permissions. So we have no read to look up the write attributes, but we have the execute set. So we can basically traverse the tree still. Meaning, for example, if we have this specific use case where we set home tux to 711 and then run cat, which has like 644 permissions, this means you basically share the path to a file, but you prevent other users from kind of traversing your directory and seeing what other files are there, which can be good if you have just like one single file in your whole tree that you want to share out to the world. Another example is like now we kind of have the permissions a little more open, so 755, and now kind of C-line can also see like the directory structure of /home/tux and like what permissions there are, what files there are, and so on. So basically, by just using like 700, 711, and 755, you can tune the access of your directories and like what other people can see. And I mean, if you're working on the Brown department machines, that's also something you might want to do or not, like depending what stuff you store there. Just be aware, a root user can always read and access your files though. All right, so one last question. What about 777 for directories? For files we already had, it's a no-no. Well, for directories, it's also not a good idea, so just don't use 777 permissions. Cool, there's one more thing left. It's even more fun, and that's special Linux permissions. And so here we have kind of some interesting additions to what exists as like basics. And that's like we have 3 additional permissions, so it's like set user ID, set group ID, and the sticky bit. And the interesting thing is that they are not related to each other at all. So before we had kind of the nice structure, you add these things up and it works, and they all kind of mean the same thing, right? But here it's a little different, and that's like there's basically some use cases where we want to do a little more advanced stuff. And the reason why I included this is not to kind of teach you the complete deep dive into like special Linux permissions, but just to make you aware that they exist and they exist for a reason. That is like with like set UID, so if you set that flag, you allow basically a process to run as the owner of the file and not the user executing it. With the set group ID, you do basically the same, but just with a group. And the sticky bit is one addition, which basically prevents, if you create a file and you could give other users read-write permissions, that they accidentally delete it. So the file is still there. And so how do we use that? Well, we can also use it in symbolic mode. So we just do like +T if you want to add the sticky bit to a file. We use G+S for the set group ID and user plus S for the set user ID. And so we can also, again, use kind of numbers for that with the same logic, just like now 4 digits instead of 3. And yeah, so the most you can do is basically 7777, which of course you shouldn't do, but like that's kind of what's technically possible. And so let's go a little why we also care about these, and that's like, so the sticky bit, as I said, we need it to prevent that other users delete a file. And that's relevant, for example, because we have a temp folder in each system where temporary files are stored. And so, for example, if we want to have a lock placed somewhere, we can create a file, and if we just want to check for the existence of the lock, we have to make sure it kind of is not accidentally deleted by like an attacking user. Hence, we need the sticky bit. So that's basically the use case for that. For the set user ID, there's another problem, and that's like when it comes to passwords. So the question is, well, the passwords need to be stored somewhere. So there is a password list or file on any machine or like cluster. However, it's kind of not a great idea if you want to change your password to always mail your admin, please change my password for me, because I just forgot it for the 50th time. So instead, there is a utility program which is called Password, which you might have already used when you registered or first logged into the department machine to change your password. And that is like, only the root user should have access to the global password list. So with like the set UID flag set, basically the password runs as root user, but you have no access, right? And so you basically trust the program to do everything correct on your behalf and run as another user, which is in this case the root user. The kind of same thingy works for set group ID, and there's basically one cool application for that, and that's like if you want to create a shared folder. And here you basically want to share your files with like a group. Here, friends. So we have C-Line is owner of the file, and it can be accessed by friends. And with the set group ID, set is like whenever you create a new file in the directory, the group of this file will be automatically friends. So you don't have to manually always set the friends group in the shared folder in addition, which is kind of convenient. I'm not sure, I think I have this also here on my demo server. So if I go into recipes, right, I can check permissions. And so let me first show you that like here, the group ID is set. Just have to find recipes, yeah. So recipes is here. So here we have an S instead of the X, which is kind of because we have set group ID set. And so recipes is a shared folder between Tux and C-Line. And so both can list recipes. Both can also access what permissions the recipes have. So we have here calamari and penguin, and we have also here calamari and penguin. However, there's still kind of one difference, and that's like calamari is open to C-Line and friends, but penguin is only open to C-Line, because C-Line likes to eat penguins, and not to Tux, because he might be shocked to discover what the actual recipe is like, right? So you can also check this. So even because the folder is shared, you can still kind of prevent other users from accessing a file within if you change the permissions. That's basically what the demonstration is about. So yeah, Tux can't access the penguin recipe, and yeah, if C-Line wants to eat a penguin, he can do so. And it's actually not a very complicated recipe. All right. Before we take a short break, I want to briefly talk about links. So links are basically, at this point, another form of files. And the idea is they're just a pointer to another file. And you create them by using ln -s, then the target, which is like some file path, and then link name. And so here it's kind of weird because usually the commands have a different order, but here the order is kind of flipped, or at least that's like what the intuition of like some persons are, including me. And so it's really good to remember for links always the target comes first and then the file name. And what this does is basically it just creates a pointer to a target and stores it under the name link name. So how does it work? Let's say Tux is in his home directory and wants to go to cline's directory, but he's too lazy to type always /home/cline. Then he can create a link. So he can do ln-s/home/cline-sl. It creates a link, which is kind of illustrated by an L at the file type. And then we have like kind of this pointer where it shows like, SL then points to like cline. So can also demonstrate that. So we have ln-s, then the target comes first. So we have home cline, I want to just call this like SL. And so if we list our files, we see we have now created a link. And so if we want to quickly jump into the directory of like cline, we can do so by doing cd home cline. We get a permission denied. Seems like cline doesn't like that. However, I think he still gives us permission to list what's in there, so we can do that. So just to revise, the permission of cline was without the execute bit, so we can't jump into the directory. Great. One last advice on links. There are like many options for links, and the command is actually very powerful. However, you can also screw up your system badly. So basically the safest default to always use is just create a symbolic link because that won't screw up your system. So basically just use ln-s and always check the order first, because if you get the order wrong, you might overwrite a file with a link, and that might be a very bad idea. For example, if you overwrite the target that you actually want to point to with like just a link name, this might be bad for you because there's no way to recover it. Cool, then I would say let's take a short 3-minute break and then we go back to streams and pipes till 5:20. So we continue 3 after 5.
When you're doing it, if you're doing it, it's 100%. You'll do it. No, do you know what odds is, bro? That's towards odds. I'm trying to figure out how links work. I can't do it. Bro, 80 minutes is too long. Bro, I've had 2 80-minute classes. Me too. I'm tired. 80 minutes in a day is disgusting. This is my 3rd 80-minute class. You can come here. That's the one. You can come here. Right before the others and like it'll be sitting in the master.
Oh, that's true. You said this is a nice room.
Yeah.
Does it go for you?
Yeah, please go for it.
Yeah, you can. You can go.
Yeah.
I'm coming to say you go.
Yeah.
Why not? You're gonna be right there.
I know that one.
Or this one.
It's gonna be kind of rough sometimes.
You can. I've been like I know, I've been to the one on the top, on the balcony.
I know I won't help it. So,
And yeah, I'm trying to get this thing to work.
What if like Andy Van Andel was there? Just chill
Is goes up there. He can't go there.
Nah, he's not. He's mad healthy.
Yeah, actually. How old is he?
He's definitely old.
He said that he's 80. He's almost
He
80.
doesn't look like that.
He doesn't look like he's 80. No, he doesn't look he's 80.
Nah,
He looks like he's 60, dude. No, he is. I've never seen a 60-year-old look bad.
I don't think he's like
How many years of 60-year-olds have you seen? I've seen a lot of 60-year-olds. A lot of 60-year-olds. What's a lot for you, too? Like,
This is not bad.
Oh yeah.
So you're the one who's scaring all the kids.
Exactly. That was the plan, but they're really good, so I don't have to do anything.
At first, when you had slide up all the time, I thought it was like a nickname. Actually, no, this is like.
Yeah, probably that's maybe where it came from. I mean, originally the story goes like this. So while I was searching for like images for the course, I just ran like penguins, and then the sea lion picture appeared, and I said, "Yeah, I should pick that." All right, cool. Let's continue with streams and pipes. So far, all we learned about was like kind of single commands. We know we can run multiple commands. We get somewhere. It works. It's great. However, we all love Lego and playing with Legos. So in order to become a more powerful user, we basically want to have commands as our tiny building blocks and create something big out of it. So streams and pipes is all about how to combine multiple commands into one efficiently. Let's talk about streams. The first two questions that need to be clarified what actually is happening when we execute a command is like, where do they actually get their input from and where do they send their output? And so in Unix, there's basically 3 special files to do that. And there's standardize, head standard, and we have standard input file, and we have 2 output files, which is like standard output and standard error. Meaning we send input or read input from standard input, and then send output to standard out. And if we have any errors, like for example permission denied or so, we send these to standard error. And because they're so important, they also got some numbers which uniquely identify them, and that's like on Unix standard input is 0, standard out is 1, and standard error is 2. And so the way this works is basically if we want to locate a file somewhere in the system, we have to give it a number, right? In terms of this is a file that's right now open, we want to read from it or we want to write to it. And this is done using a file descriptor, which is in the end really just a number in the whole Unix architecture. And so because these are all the standard files or like streams or input devices, we can also say, because in the end in Unix everything is a file, right? They get like the 3 lowest numbers. And so what's a stream after all? Well, a stream in the end is just nothing else than a sequence of characters. What the encoding for the stream is another question, but like by default you should always assume it's like whatever UTF-8 encoded characters. So again, what happens when we run a command? Well, let's dive into it. So if we run list home cline, and we have the permissions, right? So we shouldn't be a tux who runs that command. Then basically the output gets sent to standard out, and we have kind of the program, which is like the terminal, and this basically always displays our standard out after we run the command, which is basically dating back to this basic principle introduced in the first lecture, where we have the read, evaluate, print loop, which is basically our working model when we work in a terminal. And if we don't have the permissions, we get like an error, which is like, you know, permission denied and so on. And so this gets then sent to standard error, and because when we don't specify anything else, it's again displayed again in the terminal program. So far so good, nothing new. However, it gets new because we can do something cool with it. And that is, we can redirect our input and output somewhere else. The best idea is, like, let's say we have some command, it prints something out and you want to store that information. We can either just run it, copy, paste, put it into a file, upload the file or so, or we just do it directly in one command. And so how this works is basically we have a command, then we have the operator, and then we give it a file name, and this basically sends it then to the file. And to identify which stream we want to store, we can provide it the number, which is like, in this case, 1 or 2, because it makes no sense really to give the input back to the output, because it will create an infinity loop. And there are 2 flavors of it. One is like, we can redirect it and it just overrides whatever is there, or we can append it to the file that already exists. So let's see how this works. Let's say I'm in recipes. Now we got a couple more, not only penguin and calamari, but also perch and profile.jpg. And we want to list all text files that we have, and we want to store this information in all text files.txt. Because the file doesn't exist, it gets created, and basically the output of the list command gets stored in this file. If we run it with like kind of the operator in this flavor, so it's like basically 2 times larger, right? Or like stream out, append. Then it runs again over the directory. Now we have created a new all txt files. So this is included in the list, and our output gets appended to our existing file already. There's a couple more examples what we can do. We have a new interesting file which is called /dev/null, and that is like a device or a file that basically discards data. So it's another special file. So if you run, for example, list the home directory and then save this output to dev/null, it will just throw it away, which can be a good way if you want to silent errors. So you could throw away, for example, if you change it to 2, you would just ignore any error messages. We have another one which is like make dir data, and let's see what happens in this case. So we're again tux, and so tux lists first our root directory and thinks, hey, I'm a super user now, I can create directories. So tux wants to create new directory data. However, he can't do that because he doesn't have permissions to create new files on the root directory, because only the root user can do that. However, he doesn't want to see the message, so he kind of just wants to save his failed attempt into a new file, like whatever, I failed here.txt. So no output gets sent now to the terminal program, because we kind of put the standard error into a file. And so if tux wants to see all his failures working in the terminal, he can just like, you can just like output the file, and he sees, oh, okay, make dir didn't work out for me. So this is like one cool way to kind of save errors into a separate file. Yes?
Where is that text file? Where is that text file?
So we're in home tux.
Okay.
So the text file is just stored there. And so, I mean, we can also like go into it using Vim, right? So we see that's basically just the standard error what was printed out by the make dir command. And of course, maybe he wants to append some stuff. So let's say he wants to list clients directory. So this would give this, right? And he wants to append it to this file. He can do the same like this. And then if we jump again into the file, we kind of have now appended the 2 lines of like the entries of like client's home directory. All right, there's one more cool way to do stuff, and that's like using the cat command. So if we want to redirect basically the output of cat to a file, and we want to kind of do it interactively, we can do that too by simply doing cat output write something here.txt, and then now I can write something like some more stuff, right? And if I then hit like Control and D, the whole thing kind of is ended because it sends a terminate signal. And then I basically have now just interactively what I wrote in the terminal. So I produced standard in there, and cat sends it out to standard out. So it's then saved into the file.
Wait,
Yes.
what was the command that you used to like safely get back into?
I pressed Control and D.
Okay.
Complete. Which is, yeah, so Control and D. Right, as I said, there's also the option to direct two streams at once, and that's like you can direct the error stream into one file and the standard out into another file, which can be, for example, handy if we have again the scenario where C-line wants to steal Tuck's secret, and so this is like C-line running now. He wants to print out the secret. He doesn't have the permissions, so kind of permission denied will be raised and printed out to error.txt. But if he would succeed, he would get it into like stolen secret.txt. And because there is no standard out, the command only produced errors, this file will be empty, and the other one will have like the permission denied string. Right, short, I want to introduce a new command, which is called echo. Echo is something very simple, it just prints a new line with like the string you provided. Nothing too exciting, you can just type it and it prints it basically, so you can type something like echo hello world and then hello world appears. However, it's kind of cool if you want to quickly create a file, because you basically have nothing else to do than just echo the string and then direct the output to a file. So here we have just now a file with like hello world in it, which is convenient. We can do the same for input, though this is like something that's like less commonly used than like kind of output redirection. So here you basically have another echo, we send it to a file, and now we want to print out the file, and cat has the awesome property to read basically input if we don't provide it an argument from standard input. And so the way this works is basically if we can look again into the manual, we see it says something like cat, we have options which are optional, we can repeat a couple of those, then we can repeat a couple files. But then it says something here along the lines, when no file or when file is dash, read standard input. Which means if we want to pass it a file, we can do this using now kind of the stream operator just turned by 180 degrees, so it's like a less than. And then provided the file, and it basically also works. This is like the same as cat homework.txt. However, it's a difference how here the data is passed. So one is like basically we stream in from the file, and the other one is just we give it an argument, which is the name homework.txt. And so why is this kind of cool? Well, to make it interesting, we need a couple more commands. So I just listed like 3, which is like sort, head, and tail. And all these commands have the property that if you don't provide them the parameter file, which is like a file path, they will read their input from standard in. And what this basically allows us is like, if we want to create a pipeline, meaning we want to run multiple programs, we can combine them in a very elegant way. So let's have like here an example. We have here another command which basically prints some stuff to a file. Here, new line separated. So we have C-line, tux, penguin, and crabby on each line. We save it to a temporary file, temp.txt. Then we sort the lines, which is what the sort command does, and put the output out again into like a new temporary file, temp2.txt. Then we get the first lines of this temporary, save it as result, and we have to remove the temporaries. So this is like kind of one workflow, how to work with like multiple commands and save the output. However, it's kind of bad. So why is this bad? Well, there's a kind of 2 things that can be improved. First, we have to always go over disk, so it's very slow. We have to write a lot of data there, and we have temporaries that we have to delete after it. So the first step to kind of rewrite this in a better form is like we can basically just change the syntax in a way that we don't use anymore the arguments, but rather standard input. And the only thing that's left to really optimize and avoid like any unnecessary writes to disk is if we had a mechanism to connect two programs in the sense that one program basically gets its input from the output of another program. And luckily, this idea was already realized, and that is what piping is all about. So we have a new operator, which is the pipe operator, and it does nothing else than just connecting basically standard out of one command to the standard in of another command. And so our whole pipeline, which needed like a couple commands, can be now written into one line by basically saying, all right, this here sends some stuff to standard out, and then the next command sort should get the input from the previous standard out, sends it again to standard out, then this reads it from standard in, and in the end we can just save our standard out to result.txt. And that's like one cool way to quickly produce a pipeline, and that's also like what I actually did when I was downloading the PDF files in the first lecture. Great, we reached the end of lecture today, so next lecture is next Tuesday, and yeah, see you all there then. Thanks.